This is question 6 of assignment 2, and the question gives us two sets that are non-empty and bounded, A and B, and they're made up of real numbers, right? And then it gives us a definition of a set C that is the sum of elements A and B. It wants us to show that C is a bounded set, and that's the first part, and the second part is that the supremum of C would be equivalent to sup A plus sup B, and infimum of C would be equivalent to inf A plus inf B. So let's start with proving the first part. We want to show that C is a bounded set. So we know that A and B are non-empty and bounded. So that implies that for all values of small a in the set A, there exists a value A naught such that A is less than A naught. Same thing for B. And we let C naught be A naught plus B naught. Then that implies that for all values of C in C, C naught is greater than all of them, right? Similarly, using the same reasoning, there exists a value C1, which is smaller or equal to all values of C in the set C, and thus we have shown that C has a lower bound. And if C has an upper bound and a lower bound, it means that C is a bounded set, right? Capital C is a bounded set. So we've shown the first part. Second part, we want to show that sup C is equal to sup A plus sup B, and inf C is equal to inf A plus inf B. Okay, so how do we do that? Again, we let C We let C equal to the supremum of C, and we assume that C is less than sup A plus sup B. Then that implies either one of three cases is true, right? First case is that there exists a value, let's call it A, not in A. Sorry, A not in a set of real numbers, such that or the second case that exists in should be or both of case 1 and 2, right? So we let C equal to sup C, and suppose that this value sup C is less than the supremum of A plus B. And then in the first case, we assume, oops. And in the first case, A naught would be less than sup A, right? For C, for the value of C to be lower than sup A plus sup B, then let's say sup B remains the same, then sup A must be lower. Or if the value of sup A remains the same, then the value of sup B must be lower, right? Or both, right? So either case 1, case 2, or case 3 um, has has to hold for this inequality to hold. But by the definition of supremums, there are no such elements A naught or B naught. Thus, this inequality cannot hold, and C would be equivalent to sup A plus sup B because this is the lowest, because this is the lowest value possible, and that implies that sup C equivalent to sup A plus sup B, right? Okay. Now same thing. Similarly, it's the same thing again for inf. I'm just repeating what I did for the supremum. Similarly, say let let's call it C2 to inf C and C2 is an element of the set of real numbers. Suppose that C2 is greater than inf A plus inf B, then the same thing. These three cases would apply just in the opposite way. None of these cases can be true by the definition of infimums. Thus, C2 inf A plus inf B cannot exist, and C2 would be equal to inf A plus inf B, which implies that inf C inf C would be same as equivalent to inf A plus inf B. And thus we have proven that supremum of C is equivalent to supremum of AN plus supremum of B, and inf C is equivalent to inf A plus inf B.